Good morning, students. Today we are going to discuss about Bayesian classification. First of all, what are Bayesian classifiers? See, as we already discussed about classifiers in previous slides, classifiers is nothing but it is a model. It is used to predict the information. Here, like that. Here, according to that concept, Bayesian classifiers are statistical classifiers. The thing is used to predict the class membership probabilities, such as the probability of a given tuple belongs to a particular class. We are using this particular statistical classifier to predict the content, whatever the content belongs to which particular class. Here, Bayesian classifiers or statistical classifiers performs the probabilistic prediction, that is predicts class membership probabilities. As I told that it will going to predict the information belongs to which particular class, whatever the information we want to predict, like we want to observe. The thing is founded on Bayes theorem. Performance, a simple Bayesian classifiers, that is naive Bayesian classifiers, has comparable performance with decision tree and selected neural network classifiers. Here Bayesian classifiers is exhibits the high accuracy and speed when applied to large databases. The thing is used to exhibit high accuracy, like if you want to need good result, like accurate result, means obviously we are preferring this particular classifiers, maybe Bayesian classifiers. Then again the thing is going to apply in large database to predict the information. Then again incremental, each training example can incrementally decrease the probability that a hypothesis is correct. Prior knowledge can be combined with the observed data. Here again standard, even when Bayesian methods are computationally intractable, they can provide a standard of optimal decision making against which other methods can be measured. Again Bayes theorem basics. Here with this particular thing we are going to predict the information belongs to, we are checking whatever information we want to check, that particular information belongs to which classes. See, with this particular Bayes theorem we are doing all those kinds of things here. First, initially the total probability theorem, P of B equals to summation I equals to 1 to M P of B bar AI P of AI. Here according to this Bayes theorem, P of H bar X equals to P of X bar H P of H divided by P of X equals to P of X bar H into P of H bar P of X. With this particular formula we are going to predict the information. See, according to this formula, let X be a data sample or else data tuple. It can act as a evidence, like proof. Class label is unknown because whatever the database we are facing, we don't know whatever the attribute we are facing in given database. Like if you want to predict, means obviously you need one kind of class label attributes, but here we don't know that particular class label. With this we are going to predict what is that, like which attribute it belongs to a class label. Based on that thing we are going to observe, we are going to make certain kinds of classes, as we already discussed about that thing in information gain ratio, and then Gini index, attribute selection measure concepts. Here with that we are going to observe whatever the values belongs to that class label attribute. With that we are going to finding the answer. Like this, here let X be a data sample, class label is unknown. Let H be a hypothesis that X belongs to class C. Classification is to determine P of H bar X, that is posterior probability, the probability that the hypothesis holds given the observed data sample X. P of H is nothing but prior probability, the initial probability, starting probability information. Here example, X will buy a computer regardless of age and then income. Here age and income can act as a attribute. We are not concerned because the class label is unknown here. with that we are predicting which whatever the information we are we are observing. Based on that thing we are just guessing the information, like just guessing the things here. P of x probability that sample data is observed. P of x bar h, the probability of observing the sample x given that the hypothesis holds. For example, here given that x will buy a computer, the probability that x is 31 to 40 medium income. See here, according to the given that x will buy a computer, the probability that x is 31 to 40. X is nothing but here, as I told that is a simple data tuple belongs to a particular database. Here x is 31 to 40 is nothing but here age. This particular, obviously if the person belongs to age 31 to 40, obviously if he have the income 20,000 30,000 something, obviously there is a chance of buying a particular system. Obviously your answer is, obviously he may obviously he will buy a computer. Like that your x is going to say that x will buy a computer. See, that particular answer belongs to P of h bar x, that is posterior probability x says that the customer x will buy a computer based on his age and then based on his income, whatever the attribute we are facing under given database. Again, prediction based on Bayes theorem. Given training data x, posterior probability of hypothesis h, P of h bar x follows the Bayes theorem. P of h bar x equals to P of x bar h, P of h divided by P of x equals to P of x bar h into P of h into P bar divided by P of x. This is based on prediction of Bayes theorem. Informally, this can be viewed as the posterior equals to likelihood into prior bar evidence. Predicts x belongs to Ci if the probability of P of Ci bar x is the highest among all the P of Ck divided by x for all the k classes. Practical difficulty, it requires initial knowledge of many probabilities involving significant computational cost. Then again, classification is to derive the maximum posterior. Let G be a training set of tuples and their associated class labels, and each tuple is represented by an n dimensional attribute vector x equals to x1, x2 up to xn. Obviously, as I told that there will be a certain kinds of information, I mean database. That's why let D be a training set of tuples and their associated class labels, and each tuple represented by nth dimension, like n d attribute vector x equals to x1 to xn. Suppose there are m classes C1, C2, Cm. See, m classes is nothing but, think you have certain kinds of databases. Under that databases, that particular database contains set of attributes. Again, in that you have class label attribute. With that class label attribute, you are going to observe how many values are there in that given class label attributes. Whatever the values you are observing, that can act as a classes here, like m equals to, for example, according to the previous example we observed, Bayes computer. Bayes computer contains yes and no values. Those two values can act as the two classes. One class belongs to one category and another class belongs to another category. Like that, here suppose there are m classes C1, C2 up to Cm. Classification is to derive the maximum posterior, that is the maximal P of Ci divided by x. This can be derived from Bayes theorem, that is P of Ci bar x equals to P of x bar Ci into P of Ci divided by P of x. Since P of x is constant for all classes, here P of x is constant for all the classes, whatever the classes you are facing. Only P of Ci bar x equals to P of x bar Ci into P of Ci needs to be maximized. This is about how to derive maximum posterior. Thank you.